So the goal of section 12.3 is to set up and solve systems of equations. Now we practice solving them in section 12.2. So in this section, I'm going to work on solving them. Typically speaking, when you have three unknowns, you're going to need three equations. So in this case, they give us an unknown for X is the number of calories in a Big Mac. Y is the number of calories in an order of small fries. And Z is the number of calories in a Coke. So X, Y, and Z. And let's try that again. There we go. Now they give you enough information to come up with these three equations. And it starts with the total number of calories in a Big Mac, small order of French fries, and a medium Coke is 1,000. So that's really saying X plus Y plus Z equals 1,000. And that's your first equation. All you would have to do in a problem like this is fill in the number 1,000. Now we go on to the next equation, or the next sentence, which is an equivalent to equation. The number of calories in a Big Mac is. Now I want to focus your attention for a moment on the word is. What does the word is translate to mathematically? What symbol? Equals. So the number of calories in a Big Mac, well, a Big Mac is your X. So I've got that. And that is equal the number of calories in a small order of French fries. Actually, it's 270 more than in an order of small French fries. Now, when you see the word than, typically what follows the word than goes first. So the number of calories in an order of small French fries, that's your Y. So it's Y plus 270, right? Because it's 270 more than the number of calories in an order of small French fries. So 270 goes in there. And finally, the number of calories in a small order of French fries is 20 more than in a medium Coke. So number of calories in a small French fries, that was another one of our variables. That one's a Z. Excuse me, that one's a Y. And we have that the number of calories here is 20 more than in a medium Coke. So if I take a medium Coke and I add 20 to it, then I'll find out how many calories are in a small order of French fries. So this plus 20. And there you go. There's your system of equations. You can solve this any way you want. You probably want to move things around a little bit to make it a little bit easier to work on, but that's your basic system of equations you're going to work with to solve for this problem. Are we okay with this first example? Let's practice a couple more here. And again, we're just going to work on the setup. So this one's a nutrition example. And, you know, it's not something I've ever liked about these books, but they don't actually list the food here. They have gotten better, though. In the old nutrition books, they wanted you to have a diet that consisted of carbohydrate, protein, and fat, but they wanted you to have like twice as much fat as carbohydrate and protein, which is really, really awful. But in any case, we're going to be stuck with foods A, B, and C, these generic things. We want to come up with these totals. We want to come up with exactly 16 milligrams of niacin. Niacin is vitamin B3. So we want 16 milligrams of niacin, 9 milligrams of zinc, and 13 milligrams of vitamin C. Now you're going to do that by these combination of food sources. And these actually lead to your system of equations. Let's look at the first one. The first one says, okay, you get so much nutrition from these groups, so much niacin from A, B, and C. So let's kind of circle all that here, focus our attention there. And we wanted a total of 16 milligrams of niacin. Now, some of that niacin comes from food A, some comes from food B, some comes from food C, but all together that does lead to an equation. For each ounce of food A, you get a milligram of niacin. For each ounce of food B, you get 2 milligrams. We want a total of 16. So let's look at that would be. For every ounce of food A, you get 1 milligram of niacin. And 2 milligrams of niacin for every ounce of food B. And 2 times C for a total of 16. So that's your first equation. Now, do you need to write a 1 times A? Not for my money, but I'm just trying to help you see where this equation comes from. So it's probably not a bad idea to do it, at least in this first one. So 1A plus 2B plus 2C equals 16. 1 down, 2 to go. Let's take a look at zinc. So there's our zinc. How much zinc did I want to end up with?
9 milligrams.
9 milligrams, thank you. So that's a 9. Can anyone suggest an equation that I'm going to use in association with the zinc that I need?
One A plus 1B plus 1C equals 9.
Awesome. Thank you, Michael. 1A plus 1B plus 1C equals 9. Sweet. 2 down, 1 to go. So that last one here would be your vitamin C. We want 13 milligrams of that. So someone else here, I haven't heard from yet today. What equation am I going to use for vitamin C?
2A plus 1B plus 2C equals 13.
Perfect. Thank you so much. And in case you didn't quite hear that, it was 2A plus 1B plus 2, this should be a C here, equals 13. And that's a really awful looking 13. I apologize for that. But it is a 13 over here nonetheless. And there's your system of equations. So are you looking okay? Are you understanding where those are coming from? You're just taking and multiplying, you know, the variable, which really represents the number of ounces of this particular food, times the number of milligrams of a nutrient per ounce. Add it up and there's your equation. Okay, one last one here. And it's, you know, not as laid out as nice and neat as it was in the first one, but that's okay. The sum of the angles in any triangle is 180 degrees. Now we're going to be talking about triangle A, B, and C. So I'm just going to use A, B, and C as my angles. And this first line right here gives us an equation. The sum of the angles is 180 degrees. So what equation would that give me? Can anyone think of what that would be?
A plus B plus C equals 180.
Thank you. A plus B plus C equals 180. So let's just put that right here. A plus B plus C equals 180. You know what? I think I like it over here better. We need another one. Let's take a look at what else we can come up with. And I'm just getting rid of this because it's making me ill just to look at it. All right. So for the next one, let's look at the next sentence. Angle A is 10 less than the sum of angles B and C. I gave you a little clue in translating these things in one of our earlier problems here. Whatever follows the word than goes first. We can also look at this part right over here, A is. That suggests an equation. A is, so A equals, and it's whatever follows the word than goes first, the sum of angles B and C. So, okay, that'd be just B plus C. But there's a little bit more in translating this. It's 10 less than that sum. So how am I going to finish this up? A
Minus
equals,
10.
Thank you. A equals B plus C minus 10. Nice. 2 down, 1 to go.
I have a quick question for you with that,
Yeah.
if you don't mind.
Z.
Okay, thanks. So because it's saying that A is less than the sum of B and C, do we have to put that in a parentheses so that we can subtract the 10 from both of them, or is it okay to just leave it as it is?
Oh, that's a great question. This, and if I put it in parentheses, would still be the same because there's no coefficient here that's multiplying this. So, you know, either or would be fine. Yeah, no preference on that.
Thank you.
Yeah, thank you. And last but not least here, let's see, angle C is, so that's a clue right there, is 100 less than twice angle B. So let's start out with the C part. C is right there. So we got that. 100 less than twice angle B. Now somebody impressed me. What did I say about the word than?
Whatever comes after the word than is what goes first.
Right. So
And
what goes first is twice angle B.
So it's 2B.
2B. Yeah, perfect. 2B. And then I want to put in this part, 100 less than that. So what would I write next?
Minus 100.
Minus 100. So there you go. 1, 2, 3 equations and 3 unknowns. That's what you need. Now, you'd probably simplify it or rewrite it as A plus B plus C equals 180. And then I'll move these to the other side. When they change sides, they change signs. And then this to the other side. Now, when it changes sides, it's going to change signs. I also want to write this in the same order. So it'd be, I mean, you could write C minus 2B equals negative 100, but you'd probably be better off keeping it in the same order. So negative 2B plus C equals negative 100. That way they're in the same order. In fact, you can see that, you know, one way to do this would be to use, say, the first equation and eliminate the A here. That way you'll have 2 equations that just have B and C in them, and you can solve that any way you want. Substitution, addition, graphing, lots of different possibilities there. But for my money, I would clean it up before I start solving it. Get everything in nice, neat rows and columns so you can see what you got. All right, comments or thoughts on that one? All righty.
I had
yeah, go ahead.
The food one.
One more question. Go ahead.
The food question. I just had a question about that one.
All right, so let me go back up here. This one?
Yeah, so would the answers just be 16, 9, and 13?
Nope. You have to solve the
Oh.
system equations.
Okay.
So later on, we'll learn how to do some of this stuff a little bit faster on our calculator, but that still doesn't change the need to actually set up the system of equations and actually understand what the solution is. So some of that stuff I went over in section 12.2, but some of it is yet to come. We still have to solve this. I don't know, if you want to give me a second here, I could probably figure out the solution to that. So it turns out that what we need here is A would be 2, B would be 5, and C would be 2 again. So there would be your solution to this particular system of equations. Obviously, I didn't show you exactly how I got that, but you can verify compared to this that actually does solve it. 2 times 5 would be 10, plus another 2 there would be 12, plus 2 times 2 is 4. 4 and 12 give me 16, and so on. It will check. All right? Appreciate the question.
Thank you.
Anything else?